Suppose that I'm given a problem like this, where I'm asked to find 20.4% of 5,000. And that's kind of what I would call this unfriendly percentage. And so the reason I like using that percentage table, especially when I'm faced with a problem like this, and I can't use a calculator, it allows me to do some pretty complicated math in a really organized, fairly simple way. So to build it out, we're going to do just like we did in our previous investigations. So I'm going to start by writing percent and decimal, and then we're going to look at like a value of 5,000. And you don't always have to build it out as detailed as I'm doing here, but I think it's useful to sort of see where this comes from. And so we started with 100%, and we also wanted to think about what's 10% and what's 1%. And last time we stopped right there, but now because I've got this like 0.4%, I don't even want 1%, I want like 0.1% of something. And so now I can think about, okay, as a decimal, 100%, I'm simply dividing by 100, right? So I get that 1. I can write this as a decimal. I would write 10% as 0.1. I would write 1% as 0.01. And this would be 0.1%, right? A fraction of a percent. I could write this as 0.001. So if you notice, every time I'm just simply dividing by 10 each time, right? That's why I get the decimal place further that way. So when we talk about when you're moving the decimal place, what you are really doing there is dividing by 10. And so if we think about, okay, 100% or 1 times 5,000, that is simply 5,000. If I want to divide that, I want only 10% of that, I'm essentially going to drop 1 0, right? I'm moving the decimal place by 1, that's 500. 1% of 5,000 would be 50, right? I'm, again, moving my decimal place. And now if I want 0.1% of that 5,000, that's simply going to be 5. So you can kind of see that progression here as I'm dividing by 10 each time. And so if I think about what 20.4% is, well, really that is 2 10% and 4 0.1%, right? I've got 4 of those. And so now, without doing a whole lot of calculation on my computer or my calculator, I know that I need 2 of these and 4 of these. And so 20.4% of 5,000, well, I'm going to take 500 times 2 is 1,000, plus 5 times 4 is 20, so it would be 1,020. So a table works really well when you are not allowed to use a calculator, again, by finding 1% of things and thinking about multiples of fraction percentages. The other way I can do it, again, is with that equation. I have 20.4% of 5,000. Remember, if we want to know what that is, essentially I need to convert this to a decimal. That would be 0.204. Of usually means multiplication. I'm going to take that times 5,000. And now this is a great place for you to use a calculator. Absolutely get that out, and then you can, as long as you show me your step-by-step thinking like this, I'm going to get the same answer here. Okay, so 2 strategies when you're dealing with unfriendly percentages. One is to build out your percent table and to find 10%, 1%, and then 0.1% of things. And again, to do that, I'm just simply dividing by 10 each time, thinking about how that decimal place moves over. And then figuring out the multiples of that I would need to get to my specific percentage. And then the other way is to use an equation, again, simply converting that decimal into that percentage into a decimal and then multiplying it times your original percentage. Again, if I had to go the other way, if they said, okay, 20.4% of what number is 1,020, right? The math sentence I would write there would be 0.204 times some number equals 1,200 or 1,020. Again, I can use my inverse operations now to divide both sides because there's multiplication here. And so if I want to get rid of this, I'm going to divide it on both sides. So if I do it to one side, I have to do it to both. And so now I'm going to take 1,020 divided by 0.204, and I'm going to get n equals 5,000. So Either strategy works, depending on if you're allowed to use a calculator. Maybe the equation makes more sense. If you're not, maybe using a percentage table makes more sense. And also how your brain sort of wants to solve those problems. Some problems, like if I'm in the grocery store, I typically will kind of do this in my brain to kind of estimate things. If I'm being really critical and have time to like pull out my calculator and really check my work, I'll use an equation.